right? But instead of wood or logs, we're going to use numbers. We're going to use numbers, right? So I'm going to give you all the main types of functions you need to know. You need to know what a one-to-one function is. You need to know what a many-to-one function is. Jared, any others coming back to you? Any others coming back?
Yes, it's ringing bells, it's ringing bells. Have no fear.
Okay, that's good. That's good. So these are some examples of functions. And you will also need to know what a domain is and a range is. Yvonne, you know what a X is?
Yeah.
Okay. You know what Y is?
Mm-hmm.
Okay, cool. So I'm going to draw a diagram and show you all the most basic example of a function. So 2, 5, 9. Okay, 2, 5, and 9. We could work with that. And let me just say we have 4 over here, 7 over here, and we could put 11 over here. All right. So Jada, do you remember what I would call the 2, 5, and the 9? Secondary school days. You remember what you call that? This is set of X values, and this is the set of Y values. Yeah, no, maybe I go dead.
No, no. Just no.
No, okay. So this set of X values, we'd call it a domain. And this set of values here, you could call it the codomain or you call it the range. Okay. I'll probably ball in codomain and thing. What kind of fancy name is that? Trust me, it's not that deep, it's real simple. So, Jade, I remember I was telling, I don't know if you had joined when I was saying this, but I said a function is like a factory. You know, you would cut a tree, you would send it to the factory, and the product would be paper or something. Yeah? That makes sense?
Yeah.
So, X come like the log, the function come like the factory, and Y come like the product. So Jada, just by looking at this thing over here, what would you have to do with 2 to get 4?
Multiply by 2.
Okay, you say you multiply by 2, okay. If I multiply 5 by 2, would I get 7?
Okay, wait, no, add 2.
Add 2, right? Add 2. So, Yvonne, if I add 2 to 2, would I get 4?
Yeah.
If I add 2 to 5, would I get 7?
Yeah.
If I add 2 to 9, would I get 11?
Mm-hmm.
So, Yvonne, to get Y, what am I doing to X?
Yeah. Two.
That is it. I tell you, this so a function, it's like a factory. Just taking the input, which is X, doing something to it, and they get the codomain or the range, which is Y. So everybody understand this? Let me know if all you
Yeah.
understand this.
Yes, sir.
So let me give all that question now. And by the way, Jira, I told you that there were two types of functions, a one-to-one and a many-to-one. If you notice in this example, what do you think it would be? Just by the name. Would you say it's a one-to-one or a many-to-one?
It would be 1 to 1.
Right, because in the arrow going from 1 to 1,
Correct.
Vanessa, ain't you seeing that? It going from 1 to 1. Yeah?
Yes, sir.
Vanessa, if I had this scenario over here, would it be 1 to 1?
No.
No, because 5 going to 4 and 7. Yeah. That's not 1 to 1, that's 1 to 2, right? And we would call that 1 to many. So you will see more about it later on. But this is the most basic example of a function, and this one I drew over here, it's called a one-to-one. So this first example here, this is an example of a one-to-one function. One-to-one. If anybody confused, let me know, Let me know. Right? Okay. I'm going to switch up things a bit. Sheena, give me a number. Give me a number.
12.
12, okay. Any particular reason?
No, not really.
Maybe you should tell your mom to play lotto. Maybe 12 is the winning number. Who knows? Right? So
Maybe.
12, okay. Here what? In your head, right, Sheena? I want you to do something with 12, right? Like multiply it by something, add something to something. And I want you to tell me what you're getting. Do that in your head for me. In your head. So do something to 12. You could multiply it, you could add, do something and tell me what you're getting.
36.
36. Okay. That's a bit too straightforward. Jashon, ain't you know what you had to do with 12 to get 36? Tell me, Jashon, what you had to do with 12 to get 36? Jashon, if you're looking at that, 12 by what is 36?
3, sir.
Yeah. Come on, Sheena, that's too easy. Do something more to it. Do something more to it. So don't just multiply it by 3. Do something else with it. You could add something to it. You could minus something from it. Do that. Should I think of anything?
I don't know, 27.
27. Okay. All right. Cool. Vanessa, to go from 12 to 27, what do you think she did? No, wait, let me give some more examples, right? Let me give some more examples. So let me just say 13 over here. All right. Okay. Vanessa, maybe you could see it now as a pattern. Right, Vanessa?
Yeah.
Tell me, how would I go from 12 to 27? And whatever you do, it has to be applicable to 13 and 14. Right, so Vanessa, wait.
Okay. Um,
If any of you think you have it, send it to me on WhatsApp. Message me and send it to me on WhatsApp. And tell if you're correct.
I'm thinking.
Thinking. You can do it, Vanessa. You can do it.
Okay.
So I'll give you a hint, right? You have to multiply 12 by something and then add something to it.
Oh, okay. Well, multiply it by. Okay, I understand it. So you multiply by 2, and then add by 3.
Okay, yes. Yvonne, you told me to add 15. Yeah?
Yeah.
That would be wrong. Let me show you why. 12 plus 15 is 27, yeah. But if I add 15 and 13, will I get back 29?
No.
Nah,
Yeah, 28.
exactly. So, Yvonne, you have to think a little harder, right? And Vanessa, you told me the right thing. So, Vanessa, you are saying to get from 12 to 27, you have to say 2 by 12 plus 3. That's what you're saying?
Yeah.
Okay, let's do it for 13. If we do it for 13, that would be 2 by 13, right? Plus 3. Jada, mental maths here. Where's 2 by 13?
26.
26 plus 3 is?
29.
Does it work out? Do we get the 29? We do, right? Let me try 14. So Yvonne, if I multiply 14 by 2, so 2 by 14, and I add 3, do I get 31?
Yeah.
Yep. So tell me, Yvonne, what's the function here mapping the domain to the range?
So you multiply by 12, then you add 3.
Correct. And just remind me, I would call these set of values the what value? The x or the y?
The X.
Right? And I would call these set of values the y values, right? Cool. And so the function I'm going to write here, I'm going to write y is equal, you tell me, Yvonne, what do we do with the x? We multiply the x by,
You multiply X by 12.
now by 2.
Oh, shit.
Look out, language. Don't use that word too much in class, right? Because it's gonna be on YouTube, right? Yeah. So we multiplied all of the x elements by 2, so 2x, right? And then we added 3. So that's going to be the function. Jira, easy, right?
Correct.
Right. Now there's another way you could write a function. Instead of saying y is equal to 2x plus 3, you could use the notation f of x. So I'm going to show you all that as well. So instead of saying y is equal to x plus 2, sometimes they might write f of x is equal to x plus 2. Instead of writing y is equal to 2x plus 3, what do you think they might write, Vanessa? Vanessa?
Sorry?
I saying instead of writing y is equal to 2x plus 3, sometimes they might write f of x is equal to x plus 2. Right? So instead of writing 2x plus 3, you might see this in the exam. You might see g of x is equal to 2x plus 3. Now, I want it to be honest, right? Who here kind of get lost when I bring f and g into this? Tell me no. I know somebody get lost.
I get lost with the G.
All right. I like to hear that. Well, I don't like to hear all I get lost, but I like to hear all you don't know what's going on. When you admit it now. All right. So, Vanessa, a function. A function could be anything. I could call this function. So you see this function over here, I could call this f if I wanted, right? And the function f of x is just add 2 to x. You understand what I'm saying? So Vanessa, this function here is x plus 2.
Yeah.
I could call it anything I want. I could call it f of x. I could call it h of x. I could call it a of x. That's fine. This function over here, I could call it f of x if I wanted. I could call it g of x, h of x, whatever the case is, right? These are just different ways to write a function. And so Vanessa, you still don't understand that?
No, I get it.
You get it? Okay, cool. And Vanessa, this function will be an example of a what kind of function?
1-to-1.
1-to-1. Right, so I'll give you all some time to copy this down, right? As soon as you have it, let me know. Jada, how does it feel to sit down and write in a notebook after so long? How does it feel?
My job requires me to sit and write in a book.
Oh,
So
okay.
it's normal.
It's normal.
But it feels weird writing maths, definitely, with numbers.
But it hard so far, like easy.
I was pretty good at algebra, honestly. So it is difficult, but it's not that difficult.
But but if you saw this in the exam and they ask you to come up with the
I,
function,
I could think I'd be able to do it.
okay, nice. Nice.
I was never good at things like circle theorem and anything with trigonometry and that kind of stuff.
Okay, noted. Those are the trouble topics. All right. So as soon as you have this copy down, let me know, right?
And answer.
Okay, great. Shayna, you use copy down things fast.
Answer.
All right. Jeremiah, Jashon, Yvonne. As soon as you finish, tell me, right?
I finished.
Okay, great. Jira, are you finished?
Yes, I am.
Okay, good. Let's move on to a different kind of function. Right. So we finished with one-to-one. Let's look at many-to-one now. So this will be the third example. Vanessa, is multiplying and minusing or adding the only thing we could do with a number?
No.
No, and we could square root a number, we could square a number, we could cube a number, we could divide a number, and all those things we could do with a number. We could, right? Like, we could, all those are operations we could do. So let's look at a many-to-one now. Many-to-one. Remind me, Vanessa, these set of values, I'd call these values the what value? X or Y?
X.
And it's called the what?
Domain.
Right. Anybody's watched Jujutsu Kaisen?
Yeah.
Domain expansion.
Yeah.
Yeah, I got right out here. But don't put it in the exam. So I'll put domain expansion. Domain expansion.
Put
All right, this is X. All right. I'm going to put the output, and I want you guys to try to figure out what the function is. Like I said, multiplying and minusing and adding is not the only thing you can do to a number. All right. So we're going to call this function f of x, right? I'm going to put the range, and I want you to figure out what the function is. So 4, 1, 0, okay. Right, so -2 goes to 4. So we do something with -2 and you get 4. Okay. You do something with -1 and you get 1. Okay. You do something with 0 and you get 0. You do something with 1 and you get 1. You do something with 2 and you get 4. All right. So let me hear, guys, who could figure this out? What do you think the function is? What am I doing with x to get y? Right? And this is y here. I given you all 2 minutes to try to figure this out. What am I doing with x to get y? What am I doing? Let me check the chats. Anastasia, many-to-one. Yeah. That's the type of function. But so you're correct, but I want you to figure out what the function is. So f of x would be equal to what? What am I doing with x to get y? So Anastasia, how are you? You're in for 4 hours of maths? Because I'm gonna be seeing you in the Form 5 maths class after. You gonna make? No, unfortunately. And you gonna manage, don't worry. Right? Yvonne, did you figure out the function? Did you figure out what you have to do with x to get y?
No.
Okay, Yvonne.
So, are you squaring it?
Yeah, we squaring it. First of all, Yvonne, do you know what squaring something means?
Yeah.
All right. So if I have 2 squared, what does 2 squared mean?
2 multiplied by 2.
Right? And that'll be 4. Cool. So let me run through all of the cases, right? -2 squared. -2 squared would mean I'm multiplying -2 by itself. So Yvonne, I would write -2 by,
-2.
where's -2 by -2?
4.
Right? Negative by negative is plus, so +4. What is -1 squared?
1.
Right? Because -1 by -1, 1. What is 0 squared?
0.
Okay. What is 1 by 1?
1.
What is 2 squared?
4.
Does that describe the behavior you see in here? Watch.
Yeah.
Minus 2 is mapped onto 4. Yeah. Minus 1 is mapped onto 1. Yeah. 0 is mapped onto 0. Yeah. 1 is mapped onto 1. 2 is mapped onto 4. Yes. Jira, did I lose you anywhere?
No.
No. So Jira, f of x would be equal to x what?
X squared.
Correct. And another way I could write the function, I could say y is equal to x squared. So another way I could write the function. So I trust that nobody is confused with that. Right? And Jashon, why do you think I'm saying it's a many to one function? Tell me that, Jashon. Jashon, let me know if you're hearing now.
So, so I would say because yeah, you're using the same thing over and over till I get the answer. So,
Yeah, that's a good reason. Because Jashon, I'm just seeing minus 2 and 2 giving me the same answer.
yes, sir.
Yeah, so and many of them, so you can see many. In this case, many is 2, right? So these two things give me the same thing. So many go into 1. Anastasia, don't be scared to talk and thing, right? Anastasia, can you see that many of the x values are going to 1 y value? Yes? Okay, cool. So nobody is lost, right? That's a many to 1 function. I'll give you all the time to copy that down, and I'm going to give you all one where you're gonna have to figure out. This one is going to be a little trickier. So I'm telling you up front that it's going to be a many to 1 function. I'm telling you all that up front. So while I put down question 4, copy this down on the screen. All right. So Vanessa, give my number from 0 to 9.
6.
6. Okay. Things gonna get tricky here. Things gonna get tricky. Jira, what you want to call this function? You could call it f of x if you want, g of x if you want, anything. You want to call it?
G of X.
I wonder why. Right? You're gonna call it g of x, cool. So I want you all to try to figure out what the function g of x would be equal to. So x, we had to do with x to get y. So this would be the set of x values, which is domain, and this would be the set of y values, which is the range. And we're trying to figure out what the function g of x would be. So what would you have to do with x to get y? I give it only 3 minutes to figure out this one. So remember, whatever you say, it must apply to every single element right? It can't just apply to one. So Yvonne, you see how in that example you did tell me to add 15? Now it did work for one, but it didn't work for the rest. So if you notice it only working for one, then that's wrong. It has to work for all. So, Shayna, I'm counting on you to get this correct, huh? Counting on you to get it correct.
Oh, okay.
Yeah.
I figured it out already.
You figure it out already?
Yeah.
Oh, I can believe you. Yeah, that's send me working. Send me a picture or just send me a message. Preferably send me a picture you're working. I want to see what you're doing. Shayna, did you figure it out?
I think so, but I didn't finish without all coming down, so
Okay. Vanessa, what about you? What about you?
Almost.
Jeremiah, I see that you don't have a mic. Just send any questions you have at all. Send any question in the Zoom chat. I'm gonna try my best to answer it for you. Okay, so Yvonne, you're doing something that is a little wrong. I see you writing 6 to the power 6. Yvonne, if you have 6 to the power 6, that would mean 6 by 6 by 6 by 6 by 6 by 6. Yeah. Is that what you want it to mean? Tell me, Yvonne, is that what you want it to mean?
No.
Nah, you want it to multiply by itself 2 times, and
Yeah.
you want it to be 6 by 6.
Yeah.
So if you want it to be 6 by 6, right? You would raise it to what power?
2.
Correct. So make the changes to the rest, because they would apply to the rest. So you see how you have 5 to the power 5? Nah, that's supposed to be 5 squared, right? So, Shayna, did you figure it out?
yes, sir.
All right, so tell me, what is the function?
X squared minus 3.
X squared minus 3. Yes. Jada, on a scale to 1 to 10, how are you feeling about that? Do you know why they're saying x squared minus 3?
Yes, I do.
All right, so let me prove that, right? I'm gonna just complete the diagram. So 6 would go to 33, 5 would go to 22, 4 would go to 13, 0 would go to minus 3, minus 4 would go to 13. So I draw a diagram like this on purpose. Jada, would you, like, if they ask you to draw this diagram, do you think it makes sense to write back 13 or 20 or 22 twice? Do you think it makes sense to write it back twice? Yeah or no? If you look at this diagram, notice how I wrote 22 and 13 2 times. Do you think that's necessary?
Yes, because the values on the X range are both positive and negative.
Not, I hear what you're saying, but for the domain, I mean for the range, you don't want to repeat it.
Oh, yes, for the range, no, because both values would go back to as a many to one thingy. You get what I'm saying?
I get what you're saying, right? It didn't make sense to put 13 and 22 because Enter already had 13 and 22 over here. if I write back 13 and 22, why am I doing that? It's already have a 13 and 22. I don't
Then
need to.
if you rewrite it twice, it would be a 1-to-1.
Nice. It still wouldn't be a 1-to-1, Jada. It still wouldn't be a 1-to-1.
Of
You know why? Watch.
Why?
N minus 4 still going to 13 and minus 5 still going to 22. Look at this.
Yeah.
If I write it like this, and many of them still going to the same answer. Watch. 5 going to 22, and minus 5 still going to 22.
Correct.
So that would be a many to one still. Yeah. Right? So we wouldn't put back 13 and 22 twice. You would write it like this, and this would be correct. Right? And I would show that minus 4 is going to 13 as well. And I would show that minus 5 is going to where? Tell me, guys, minus 5 is going to where? Is minus 5 going to? Tell me, Sheena or Vanessa, where's
Oh,
minus
sorry.
2?
22.
22, right? Great. So let's just do a couple examples. Now, when you are doing a functions question, and they give you it in this notation, what you are going to do is you're going to replace the x value for the one you have. So Jada, let's start with 6, right? So Jada, if the x value here is 6, the proper way to write it will be j of what? So Jada, if x is 6, I'm going to replace x with?
6.
So I'm going to write j of 6 as the way to say it. X is 6, so I'm going to replace the x with 6, right? 6 squared minus 3. What is 6 squared?
36.
36 minus 3 is?
33.
Correct. Let's try j of minus 5 this time. So tell me how to write that. How would I write that? So Jada, this is your function, eh? This is your function. I'll give some other people their functions just now. But how would I find j of minus 5? How would I do that?
Negative 5 squared.
Like this?
Negative 5 in brackets.
Right. Guys, Yvonne, would you have had wrote minus 5 squared like this? Yeah?
No.
Nah. Vanessa, you think you could explain why you shouldn't write it like this? Okay, Vanessa, okay, I can try. If I write it like this, where's the only number that's gonna be squared here?
If negative 5.
No, the 5.
Oh, no, the 5.
Yeah. If I write the squared over here, only the 5 is going to be squared, but Vanessa, isn't the whole number minus 5?
Mm-hmm.
So you need to put minus 5 in brackets. Because Jada, I want to square minus 5. I don't want to square 5. So Jada, if I had minus 5 squared, that would be minus 25. But I'll be wrong. I really want it to be minus 5 in brackets squared because that would be minus 5 by minus 5. Yeah, Jada, good, right?
Yeah, we are.
Cool. Right, and now be minus 3. So minus 5 squared is? What's minus 5 squared?
$25.
All right, 25. 25 minus 3, that would be 22.
22.
So these are just some couple of examples, right? So, Jira, you can see why is a many to one function, and you can see why?
Yes.
Because many of the elements in X go into one element in the Y. And you can see that, like watch. N4 and minus 4. And both of them go into 13. You can see that. And you can see that 4 and minus 4.
Yes.
So many of them go into
13.
which is 1, right? So, Yvonne, you understand that?
Yeah.
Yeah? Okay, cool. So these are the two types of functions you need to know. So I will allow you all to make the corrections and take down the notes. So do that and we'll move on. Vanessa, do you know how to plot a graph?
Yeah.
Yeah? Okay, cool. Did you know that all graphs are just a function on a function? It's just a diagram of a function?
Yeah.
Okay, cool. Like if you have y is equal to mx plus c, that's a function. Yeah. If you have 5x squared plus 3x plus 5, it's a function. So all algebraic expressions or equations are functions. Yeah. So as soon as you have this copy down, let me know and we're gonna move on.
I finished.
Finish? Nice.
I'm done as well.
Right? Jeremiah, drop in the chat. You understand what's going on or you're having a hard time understanding what's going on? Tell me. Right, Joshua, you have everything copied down? Is there anything that you don't understand? Anastasia?
I have everything copied down, so I understand it.
Nice. So let's look at an example of something that's not a function. Right? Not. So, Shina, aren't you brave?
Partially.
Partially. Nah, I feel you brave, right? So I want you to try to explain why this is not a function. I think you could do it. I root in fair. Okay. Yeah. So 1, 2, 3, 4. Okay. And I'm gonna put in these values in the range 3, 7, 9, and 20. Okay. So I just doing a bunch of madness here. That's literally what I'm doing. Now, without me saying what this is, I want you to see if you can figure it out, Sheena. So it looked like it looked like in this example, it have 1 being mapped onto what?
Many.
So you'd call this a
One to many, I guess.
yeah, maths is very straightforward, to be honest. This is a 1 to many.
Um,
Jada, you understand why we call it a 1 to many?
Yes.
You're probably saying, well, 3 only going to 9. How we still calling it a 1 to many? Well, maybe Jada, if it had more elements here, maybe 3 would have go to something as well. You never know. Right? But Jada, ain't you seeing that 1 going to many? I think all of us could see that. 1 going to many. Right? Anytime you see 1 going to many, that's not a function. That kind of suspicious. Right? So, Shayna, the stage is yours. See if you could explain.
it is not a function because you're doing the same thing to every number coming down in X. So you can get two answers to the same thing, I guess.
Exactly how you get 2 answers for the same thing. Let me explain that in the simplest way possible. Yvonne, you there?
Yeah.
Okay, Yvonne. Let me just say you buy ingredients to make a cake, right? Yeah.
Okay.
You could cook by chance?
Yeah.
You could say you can make a boss cake.
Yeah.
Okay. So let me just say buy the ingredients and make a cake, right? You think those ingredients could give you a salad?
No.
No, that don't make sense, right? If you buy the ingredients to make a cake and then to go make a cake, yeah or no?
Sorry?
If you buy the ingredients to make a cake, and it could only make a cake,
Yeah.
yeah, Jada, you understand what I'm saying? If you buy the ingredients to make a cake, it could only make a cake. It can't make a salad. That makes sense?
Yes.
So, Jada, if I had a function here, if the function was, I don't know, this is not a function, so I can't really use this. Let me use this. So, Jada, if I use 6 for the x value, and if I plug it into the function, I could only get to the 3. And I would only get to the 3.
Yes.
I would need to change the x value if I want to get a different answer. But if I put 6, then how will I get more than one answer? Right? Sheena, let me know if you understand what I'm saying.
Yes, I understand.
Because Sheena, and if I put in 6 here, how am I going to get another answer? That's the question. How? Jashon, if I put in 6 into this, or any number, how much answers would I get, Jashon? Let me just say I put x is 2. 2 squared minus 3. 4 minus 3 is 1. Jashon, how much answers did I get there? If I put 2 into that function, again 1. So, how much numbers is that there, Jashon? 1 is how much numbers? Can I hear in Jashon? Vanessa, if I put 2 into the function there, my output is just 1. Am I getting multiple answers?
No.
No. So, I hope you understand what I'm saying. If you buy the ingredients to make a cake, how you gonna make a salad? The same thing over here. If I'm putting in 6, then I could only get one answer. So this is very wrong, because how could I put in 1 into a function and get both 3 and 7? That don't make sense. So Yvonne, you understand why this is not a function?
Yeah.
All right. Right. So Joshon, Joshon, you there? I'm not hearing Joshon at all.
Yes.
Okay, Joshon, I'm now hearing you. Joshon, first of all, do you understand why I'm calling this a one-to-many function? Well, sorry, not a function. Do you understand why I'm calling it one-to-many? Tell me that first. You understand why I'm calling it one-to-many? Yeah or no?
Yes, sir.
Okay. All right. Do you understand why it don't make any sense for 1 to give you both 3 and 7? Joshon, do you understand why 1 can't give us both 3 and 7? That part confusing you?
Yes, sir. That confusing.
Okay, Joshon, let's look at this example, right? So Joshon, if we have a function x squared minus 3, actually, let me do an even simpler function. Let me just say we have a function y is equal to x plus 2, right, Joshon? Joshon, if you put 2 into this function, that's going to be 2 plus 2. Where's 2 plus 2, Joshon?
4.
So Joshon, if I put in 2 into this function, what's the only answer I'll get?
4, sir.
4. Joshon, could I get any other answer?
No, sir.
No. So Joshon, for something to be a function, the x value needs to be mapped onto only one specific y value. It's all confusing, but let me run it back one more time. So Joshon, you understand that 2 could only give you 4. Yeah?
Yes, sir.
5 could only give you 7. 9 could only give you 11. It can't give you anything else. So Joshon, when you come and see something like this diagram here saying 1 could give you both 3 and 7. That make any sense, Joshon?
No, sir.
No. So anytime you see one element being mapped onto many, that'll make sense. That's not a function. right? So Joshon, again, 4, if you put in 4 into a function, you could only get one value. But in this diagram, it's saying you could get 9 and 20. Again, that don't make sense. So one-to-many is not an example of a function. Is there anybody confused?
Oh, so I understand also.
Nice. Glad to hear you understand that. Anybody confused?
No, sir.
No? Okay. Sheena, I'm gonna give you a job. You in charge? A sound design. If it had too much silence, pull up the elevator music or the cricket audio. Yeah. Before we move on, Jira, I have a question, right? What is 9 plus 10?
19.
Oh, you don't get, you know this joke?
Wait, I feel like I do. Oh yeah, I was gonna say 21. Oh my god.
Yeah. I just do that sometimes, I feel like I do that on a maths paper at time. I ain't gonna say 9 plus 10 is 21. I'm being real. Yeah. Right? So we know how to detect if something is not a function. So let me just do a quick recap before we move on. A function in a function, right? In a function, you'd have these elements here. What would I call these elements? What? Somebody tell me. What would I call these elements? Do not recap before we move on. Shina, what would I call these elements? The what?
The domain.
Right? This is the domain. And is the set of what values? X or Y.
X.
Right? What's the name of this?
Codomain. Or like range.
I just remember range more, so I just put range. But if you all put codomain, it's fine. Right. Shina, in this example, this is an example of a what kind of function? What kind of function?
1-to-1.
Right. 1-to-1. Lovely. Cool. Gonna call this X, gonna call this Y. 2, 7. Actually, right. Okay. Shina, in this example, what are you noticing? What are you noticing?
Is many to one.
Wait, say that again?
That it's a many to one.
Right. Yvonne, do you know why she's saying that is a many to one?
Because because one of the numbers going to the same one as another one.
Exactly. So many of them go into one end.
Yeah.
Is many to one an example of a function?
Mm-hmm.
Yeah, this is a function. Last one. All right. Anastasia. Anastasia, what kind of quote unquote function is that? Is it even a function, Anastasia? Anastasia, don't be scared to unmute and thing, You could unmute. I see you saying nope. Yeah, this is not a function, right? Could somebody tell me why it's not a function? What would I call that?
That's a one-to-many.
Yeah, because nth one of them going to many.
Yeah.
I think we okay now. I think we know what a function is, the basics of a function. Let me show you how to see if something is a function on a graph. So we're gonna look at the vertical line test now. Did anybody ever hear about the vertical line test?
No.
Wait, just sorting out something here. Give me a second. Yeah. So nobody ever heard about the vertical line test. Jada, you know about that? You remember it?
I think so.
First of all, do you all know what vertical means? Now hear this, don't be ashamed. I myself used to mix up vertical and horizontal. Jada, would this be vertical or would this be vertical? One or two?
One is vertical.
All you agree? Jashon, Yvonne, Sheena, Vanessa, all you agree?
Yes, sir.
I should.
Okay, good. Everybody know what vertical means? Lovely. Right, so the vertical line test, all you're gonna do is just draw a vertical line and see if it cuts any graph 2 times. If it does, it's not a function. Very, very simple. So vertical line test. Test if it's a function or not. I would call this the what axis? Somebody tell me what the vertical axis is called the what? What do I call the vertical axis? The
X.
y-axis or the x-axis?
X.
No, the vertical axis is called the y-axis. The horizontal axis is called the x-axis. Don't forget that. Don't mix up that, please. You can't afford to mix up that, right? So if I were to draw,
That's why
oh, somebody was talking, Vanessa?
yeah, that's why I lose my marks in that term.
Yeah, you can't mix up the y and x, right? Yeah, right? All right, so I'm going to draw a graph. So, guys, there's a curve or a straight line. If you had to say, what is that? That's a what? I just don't draw a line. I cannot tell you the answer just now. That's a line, right?
A straight line.
That's a straight line. To do the vertical line test, you're going to draw a vertical line anywhere. Like just draw a vertical line anywhere, and you want to see how much times it's cutting the graph. So, Jira, if the graph is a blue line, how much times did the red line cut it? Tell me, Jira.
Once.
Once, right? Okay. And let me show you where's the connection. Jira, a x value could only give you one answer, like one answer. It can't give you two, right? And we just now discussed that.
Correct.
So we're going into a bit of some advanced stuff, but watch. If it cuts in the graph at one point, it means that for this x value, it only gives you one y value, which is what we know. And we know that, Jira, enter x value could only give you one y value. We know that, right? So if you do the vertical line test, and you see one intersection is a function. So this is our function, right? This is our function. Cool. I will go it over at the end. Don't worry. All right, so this first example is our function, right? One is a function. Cool. I'm going to give you all a second graph. I want you all to draw a vertical line anywhere, and I want you to tell me if it's a function or not. If it's a function, it will have one intersection, right? If it's a function, it's supposed to have one intersection, right? So Yvonne, hear what I'm saying, right, Yvonne? Whatever graph you get, if you draw a vertical line and it cut it and it passes through it once, it's a function. If not once, it's not a function. That's the vertical line test. Pretty straightforward. All right, so I want you guys to draw this graph for me. So draw this graph. I want you to draw a vertical line somewhere. I want you to count how much time it cuts the graph, and I want you to tell me if it's a function or not. So I'll give you only 3 minutes. No, take 4 minutes. Take 4 minutes. Take 4 minutes to do that because you had to draw. Joshon, tell me if this vertical line test confusing you. Tell me if it's giving you some trouble.
No, it's not confusing us.
Okay, good, good. Glad to hear you have it unlocked. So yeah, what I want you guys to do for me, I want you to draw question 2 in your book. Draw a vertical line and count how much times the line cuts the graph. If it's 1, it's a function. If it's more than once, not a function.
So can you say that one more time? Say it's something else also.
All right, so Joshon, I'm saying I want you to draw question 2 here, or example 2, right? That's this over here. I want you to draw a vertical line somewhere, and I want you to count how much times it cuts the graph, which is the blue curve over there. If it cuts the graph once, it's a function. If it doesn't, if it passes through more than once, it's not a function. So a little under a minute. Jira, did you draw the diagram as yet and draw the vertical line?
No, I'll draw my graph.
Okay, word. Anybody else feeling theta gyro? I could do it a good lamb gyro right now. Unless all they don't like gyro, which would be crazy. I seen something in the chat there. You're feeling for 2? Way. That's a lot. I myself could only eat 1 gyro. 2 is crazy. But big up you. I saw waiting on somebody to send me a picture of their answer. Right, as soon as I get a picture, I'll resume on the screen. All right. I didn't get a picture from anybody yet. Yvonne, getting through?
Not really.
Tell me, what giving you trouble?
Well, I didn't really hear what you say because my sister did come in the room now.
Okay, so I want you to draw this in your book, right? Draw this,
Okay.
and I want you to draw a vertical line anywhere. And I don't mean like over here and over here. I have to like pass through the blue curve.
Okay.
If it cuts the blue curve one time, then it's a function. Yeah,
Okay.
that's all way to do.
I don't do that.
All right. Well, send my picture of it. Jira, that's correct, right, Jira? You just have to put in, you have to put in y and x. Actually, wait. Jira, did you extend the graph? I see you did this. Jira,
No, I didn't.
I see you drew this.
It's something along that.
No, you literally just drawing back this. So exactly where you see here, you're drawing this back. You're drawing that back. That's it. And you're drawing a vertical line somewhere. Anywhere you want. So draw it back. Make sure and put y and x. And I want you to draw that graph. Like this exact thing, guy. That exact thing. And I want you to put a line somewhere like that. Sheena and Vanessa, I didn't get anything from you guys yet.
Oh no, so I did it. My phone just not next to me. So just
I'm gonna send it now.
Okay, cool. Yvonne, how much times did the vertical line cut the graph?
One time.
So is it a function?
Yeah.
Yeah, that's it. That's it. That's it. Yeah. Now, when you draw any vertical line, draw it kind of dash like this. So so nobody would confuse it for the y-axis. Right? Just draw it.
Alright.
Right, but good job, Yvonne. Vanessa. Again, yeah, draw the vertical line dashed, but other than that, that's correct. And Vanessa, the line cut in the graph how much times?
One.
Yeah,
Once.
right?
I don't know how it ended up so wide.
I don't know. Probably eat too much gyro. Probably eat too much food. Yeah. Vanessa, your graph eating too much.
Really?
Yeah, it's wide. Yeah. Look like it burns some weight. All right. So Jada, tell me, what giving you some trouble?
Wait, sending you a picture.
Okay, no problem. Joshua, I didn't get anything from you. Anastasia, send me what you have if you're taking notes. Right? And Jeremiah,
I'm
let me know
not
if you
home. I've stayed at any truck before. I'm not home. That's why I'm not on meeting my mic.
Oh, okay. All right.
Yeah, I'm traveling home right now.
Well, big up you. You're really putting in the effort. I applaud that. You go mash up the maths.
Big up.
Yeah, big up, big up. You're gonna eat that maths like gyro. You're gonna have gyro in that wrap. I mean, what's it? You're gonna have maths in that wrap. Yeah. All right. So, Jira, is any picture?
Yes, I did.
Okay, say no more. All right, so yeah, that's correct, Jada. And how much times did it cut the graph?
Once.
Yeah, so it's a function. No, I'm not judging. I never judge. That's never my aim. I just want to understand how come you draw a different graph?
What do you mean like that? I think that's just like how I remember doing it back in my day. That's what I tell you. I think I remember learning something along that lines, and it used to be correct.
Now, what you have there is a whole different graph. There's a whole different function. So that wouldn't be correct. If this is the function here, if this is the function, then you can't change it up. This is what the function is. Once we finish with this, I'll show you guys how to plot the graph for a function. Alright, so you can see what I'm talking about here. But this is the basic concept. All you're doing, you're just drawing a vertical line anywhere, and you're looking to see how much times it cuts in the graph. Now, Jada, does it make sense to draw the vertical line over here?
No.
Now, how to draw it somewhere where the graph is, right? Notice it's cutting the graph over here. This is one time. I don't know how much square come in, right? This is a function. And Vanessa, you know what kind of function I would call this? So this one, I would call this one a linear function. This is an example of a linear function. And what do you think I'd call the other one? Does anybody know what that is? I take it as I know. Tina, you know what this is? Starts with Q. Q. You place real quiet, right? This will be an example of a quadratic function. All right. So, third and final case. Okay, I give it only 2 minutes, right? And no more or no less, just 2 minutes. I want you all to draw that graph, put a vertical line, and tell me if it's a function or not. Tell me. Right? 2 minutes. Shina, and you was doing hard maths with me? And you doing hard maths?
Yes.
Yeah.
Mm-hmm.
You will have to learn the equation of a circle, which is look like this: x squared plus y squared plus 2fx plus 2gy plus c is equal
So I want to be happy right now. Wait,
Let's say that again.
I'm choosing peace at the moment.
Okay. You do this in school as yet?
So I do
I
add
know
maths, and
so.
I never learned that.
Serious?
I swear.
Nah, I don't know what kind of maths I was doing. This is the general form for a circle, and then I have the one that is x plus f squared, right? Plus y plus g squared is equal to r squared. Something like that. Yeah. Have that one. So the general form and the standard form. Never learned that.
No.
That's alarming. Yeah.
No, but that explains why I didn't pass our maths.
Them teachers didn't do you justice, boy.
I'm not even gonna lie, my maths teacher was like, no, she couldn't teach number one and number two. She was like,
Wait, wait,
unsure.
wait. I thought you was going to say always pregnant. I thought you was going to say that.
Nah, she wasn't always pregnant. And I don't know how to have kids, you know.
But you know that joke? Um, all the, I think it's the English teacher. The English teacher is the one who has always been pregnant. Not the math
Yes.
teacher.
My IT teacher was always pregnant. Every term.
That's
Couldn't even
crazy.
stop.
And them still get paid, you know. Them still get paid while they're not working. All right. So, Yvonne, is it a function or is it not a function?
Not a function.
Not a function because I cut in the circle at 2 points.
Yeah.
Right. So I could move.
Um, My final look, Matthias, it is always the English teacher that is pregnant.
Anastasia, you're
I
saying something?
don't know how I passed it.
Anastasia, you're saying something? I'm not hearing you properly. I think that was a mistake. Jada, so you understand what we're doing, right? We're just drawing a vertical line and we're looking to see how much time it cuts on the graph. If this is so Jada, if this is a circle, right? Can you change it to a line? Yeah or no?
No.
No, you can't do that. If it's a circle, right? How you go change it? And it cuts the graph at 2 points, so this is now a function, not a function. And right now, I feel like I can't function. As a joke, I think I could function quite well. Right? Anybody else feel like they can't function?
Mm,
You know, gosh, Kelly. And negativity. Shana, you too negative, you know.
no, it's the lack of sleep. It's getting to my head.
If you get into your head, just know your head might look like this. That's a bad joke. You should get some sleep before your head starts to look like this.
Yes.
Right? So this is now a function. Why? There are 2 points of intersection. Right. So, Shayna, and for those of you guys that care to learn the maths a little deeper, I want to explain the actual concept and why this works. So, Shayna, and we just now say that one value for x could only give me one answer. Yeah?
Yes, sir.
So watch, and you see in here 1. Okay, in this example, 1, they say in 1 could give us 3 and 7. That make any sense?
No, sir.
No, this don't make any sense. This thing homeless. Because it don't making any sense. It don't no money. Right? Like me sometimes. But anyways, yeah, so Shayna, if we look at these things here, these are functions. These are functions. And you seeing that x only giving us one answer. You seeing that, right?
Yes, sir.
So for instance, if x is 2, where's y?
4.
Could it give me anything else?
No, sir.
So what I'm saying is the for one x value, you should only have one y value. That's what I'm saying, right? That's what I'm saying. You understand? You think you understand what I'm saying?
Yes, sir.
Okay, Yvonne, do you understand what I say? Like what I'm saying? Be honest with me. Be honest if you think I'm saying not garbage. Tell me. You understand what I'm
You
saying?
know, yeah,
So in this example here is a function, right? So NTC and -2 could only give me 4.
yeah,
It can't give me anything else, right? So when we do the vertical line test, this is what's happening. So Yvonne, when we draw the vertical line, this will be the x value over here. I could probably call it 4, and this could probably be 20. So Yvonne, look at what's happening here. So if x is 4, y would be 20. See now? This is a little example. See now? If it's confusing, you tell me. I didn't show you how to sketch the graphs as yet. So I understand if it's confusing. But tell me if you understand a little bit of it.
yeah,
Okay, so graphically, 4 is only giving me 20. And you can see that 4 is giving you 20. It's not giving you anything else.
yeah.
Jada, when you look at this, right? This x value here, this x value is giving you how much y values? Jada, tell me if it's confusing, yeah? Tell me. Jada?
2.
2? No, what? Check it out, check it out again, right? So over here and then over here. It only have one value. It's giving you
1.
1, right? Look at this example again. What? Check this out. X here, Y here. How much? How much value is it giving you? Tell me, Jada.
1.
1, right? Over here though, watch. How much you giving me?
2.
So we just learned that if something is a function, the x value should only give you one y value. But this is x over here, and I'm giving you two y values. That can't be a function. Can't be a function. That don't make sense. So Jada, you understand why how the vertical line test works? At least some of it?
Yes, I do.
Okay. Vanessa, what about you? Do you understand a little bit of it? If not the whole thing?
Yes, sir.
Yeah? Yeah, okay, cool. Right. So we know it's a function. We know the types of function. We know the vertical line test. Cool. Let me show you how to sketch a function. Let me show you how to draw a graph now for a function. So we're gonna start off simple, right? So plotting the graph for a function. Anybody in class here plotting? Anybody in class here plotting? Yvonne, you look like you're sounding like you're gonna plot something. Are you plotting something?
No.
Nah. You're not plotting against the ops? You have any ops?
No.
You don't you genuinely think you don't have no ops?
No.
Okay, that's good. By the way, you know Nicholas Singh?
Mm,
He just graduated Shiva Boys. He was in Form 5. So you know who Nicholas Singh is?
no.
You know who Achilles is?
No.
You don't know none of these fellas.
No.
How about Adrian Jagmohan?
Yeah, I know he.
Okay. Cool. Right. Jira, are you plotting against the ops right now?
No.
Yeah? Yeah. Well, that's good. I'm glad to hear nobody in class here plotting against the ops. Peace is the answer. You know, sometimes violence is the answer, but if you could avoid the violence, that's good.
What are you teaching? Violence is never the answer.
Now, hear what I'm saying, right? In history, most of the problems were solved with wars. Now, I'm not saying war is a good thing, right? Obviously, war is a bad thing. Nobody really wins. But like, Jira, hear this example, right? Imagine you have a very insane criminal, like a crazy criminal, right? That just doing the most vile crimes. If Jira, do you think no violence would be needed to, or like nothing would need to be done to avoid that, like to rectify the situation? Tell me, Jira. What do you think?
Not necessarily.
Well, I view violence as excessive physical force or oppression or like just like physical force. And like and to need police and thing to hold up the criminal. I view that as violence.
Pretty much, yeah.
So I mean sometimes it is a solution. You know, like if somebody bullying you and nobody's standing up for it, maybe you might need to stand up for yourself. So but most of the time, try to avoid that. Try to just be peaceful about it. But anyways, let me show you how to plot in maths, not against the ops. So if you want to plot a graph, it's very straightforward. Yvonne, I want you to give me a function. Give me a function. Simple function. We can start off real simple. So give me a function, Yvonne.
Okay. Mm, 7 squared.
Nah. Yeah. You have to include x in it. Because Yvonne,
And
in a function, so you can think of a function as a skeleton. And you could put anything into the skeleton, right? So you need to put x somewhere. So if you were to say x squared, well, that would be fine.
okay. I,
Let me look at x squared. So I'm going to put down some values and we're going to plot a graph of it. Now to plot a graph, you need points. Jada, does that make sense? If you want to see how something looking, and you would need, like, if you wanted to draw something, I'll probably remember, Jida, you know about connecting the dots? It used to be in them coloring books. You had to connect the dots.
Yeah, I do.
Is the same concept, Jida. If I want to see how that function would look like, I would need points that would connect. Same concept. So to generate points, you need to plug in X values and see what you're getting for Y. So let me just give all you a couple X values. So we could use 2, 1, 0, -1, 2. I could even do 3 and -3. Sure. So if my function is y is equal to x squared, right? If that's my function, what am I doing with it? Yvonne, what am I doing with these x values? Tell me, Yvonne. If I have those x values, what am I going to do with those x values? Yeah, just tell me the function is y is equal to x squared. So what am I going to do with the x values?
Not too sure, sir.
All right, so Yvonne, where's the function here?
Y equals x squared.
So to get y, what you had to do with x?
You just find x.
Now you have to square x.
Oh, okay.
Check it out, right, Yvonne? They are saying y is equal to x, whatever x is, squared. So let's do the first one together. So if x is 3, then to get y here would be equal to 3 squared. Yeah or no?
Yeah.
What is 3 squared?
9.
9. So the first one is going to be 9. Yeah?
Yeah.
Second one.
Two
Y
squared. Y equals 2 squared.
right? 2 squared is?
4.
All right, Jada. For 1. X would be 1 here. So you would say what?
1 squared.
Which is?
1.
Right? This one was 0 squared, which is just 0. Okay, Vanessa, this would be what?
Oh, wait, one -1?
Yeah, in brackets, right? That would have to be in brackets. So -1 squared is?
1.
Right? Then we have -2. So again, I would have to put that in brackets, -2 squared, and that would be equal to,
4.
right? The last one would be -3 squared, which would be?
6.
No.
No, 9. 9.
Catch you lacking. Yeah, catch you lacking, right? So here what? Did I confuse anybody at all? The function said y is equal to x squared, which basically means any value for x, I'm taking it, I'm squaring it, and that would give me y. Yvonne, you confused?
No.
Jeremiah, let me know if you need chat if you're confused. Vanessa, you confused?
No, sir.
Jada, you good?
Yes.
Jashon, Sheena, Anastasia, are they good?
Yes,
No,
sir. Yes, sir.
Yeah? Okay. So I'm gonna write 9 here. Yvonne, what am I gonna write here? Remind me, what did 2 give me? When x was 2, what did it give me?
4.
When x was 1, what did it give me?
1.
When x was 0,
0.
when x was -1,
1.
am I gonna write back 1 here?
No, because I already have 1.
Exactly. Jira, you see what happened, right? -1 would give me 1, but why would I write 1 when I already have 1 over here? Understand what I'm saying, Jira?
Yes.
Yeah. To already have 1 over there, don't need to write it back. So let's do the mapping now. 3 would go to 9, 2 would go to 4, 1 would go to 1, 0 would go to 0, -1 would go to where? Somebody tell me, -1 would go to where?
1.
1. -2 would go to where?
4.
Minus 3 would go to
9.
right. Now, do you all know what a point is made up of? Yeah or no? A point is made up of what values? Gina, see if you can remember this. If I plot a point on a graph, the point would be comprised of the what values?
X and Y.
X and Y. So let me just give all you a quick crash course on plotting on a graph, on the X and Y axis or the coordinate plane. Right? So this is Y, this is X. Let's just say I wanted to plot 2, 3. Right? Let me just give me a second there, guys. 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2. Good. So we have the Y and we have the X axis. Vanessa, since you mix up your Y and X axes, you're not going to call it. Not going to call it out. All right. So Vanessa, Y vertical, X horizontal. Yeah?
Yeah.
A point is made up of an X value and a Y value. Yeah?
Yeah.
This is our point. When you're plotting a point, you put down the X movement first and then the Y movement. Now, Vanessa, if you're on the X-axis, you could either move in what direction? If you're on the X-axis, you could move in what direction?
Positive and negative, left and right.
Left or right. Cool. If you're on the Y-axis, you could move either.
Up or down.
Great. I hope everybody understands that. So now let's start a plot. So Vanessa, we're starting off with the X movement first. So this would mean, so we're going to start at the origin. Should I probably explain what the origin is? The origin is the center point over here, 0, 0. Yeah, that's the origin. You're always going to start from the origin. So Vanessa, we're going to move 2 spaces to the what? It's positive 2, so we're going to move 2 spaces in what direction?
Right.
Right? And then I have a Y value of 3. So then I'm going to move 3 where?
Right. No, up.
Up. So I'm going to end up over here. Yeah? Tell me if that makes sense.
Yeah.
Right? Jada, did I confuse you with that?
No.
Nah, so Jada, let me plot a point, right? Let me plot minus 1, 4. So I'm going to start off at the origin. Then I'm going to move 1 space where? 1 space to the left or to the right?
The left.
Right? And then I'm going to move how much spaces up or down?
4 up.
Right? So I'm going to end up over here. So you feel like you fully understand this, right?
Yes.
Nice. Yvonne, I might tie up here. We go see. Right? So Yvonne, what about 0, 3?
You're gonna have to put the point on 3.
So over here?
Yeah.
Right. Because if this is the horizontal movement and it has 0, that means you're not moving left or right. You are only moving 3 up. So you'll end
Yeah.
up over here. Great. Nice, man. Seems like everybody is familiar with these things. You should. Right. Okay, I want somebody to read off this point for me. Shayna, what's that point? Read it off for me. What would that point be? So the horizontal movement first. Shayna, if I want
Sorry,
to
yes, sir.
read off this point, read off that point for me. If you were to read off that point, how would you do that? So tell me the X first, then the Y. What was the horizontal movement there? Tell me, Shayna. If I want to go to this point over here,
You go, we want 3 to the right.
3 to the right, and did I move up or down?
No, sir.
So,
2 to 0.
right. Cool. Excellent. All right. Sheena, pick a victim.
Mm.
Pick somebody.
Oh, no.
You're scared you might get some ups.
Yeah.
That's okay. Pick somebody.
Oh,
Anybody.
um, um,
Unfortunately, I don't have somebody named Arm in class.
sorry,
Okay.
Jashan, what is it? What's his
Jashon? Okay, you were nominated. So Jashon, I want you to read off this point for me.
Seven.
What would that point be?
Two, come. You hear me? 0,20.
Nah. It was close. So it would be 0 here. Why? It didn't move left or right. It just went down. Because it's going down, that should be -2. 0, -2. That's it correct.
Negative
Right? I'll give you a
17.
chance. Let's say that again. I didn't hear properly. Say that again.
So I didn't see that. I didn't see that. Sir.
Well, I'll give you a chance to
So I
read it.
didn't see it. Sir. I was watching where the red dot was.
Oh, well, I'll give you a chance to redeem yourself, right? Try to read off this point for me. Read off this point for me. So the purple point.
0, -3.
Not quite. Remember, you're always putting down the horizontal movement first. So left or right. To go to this point, you'd have had to go 3 to the left, right? That's the first thing you're putting down. That's for the X. And did you move up or down?
No, sir.
Nah, so this gonna be 0. Yeah.
Hmm.
One last chance to make up for the mistake. What would this point be?
-4,0.
Right. Yeah. Jada, what would this point here be?
0 and 0.
Cool. I think all of us could plot a point by now. All right. So now we could actually move on to the fun part. So Jada, we put in some X values into the function and got some Y values. Yeah.
Yeah.
So I want you to tell me the first pair of values. So when X was 3, what did we get for Y?
9.
Right? So that's going to be 3, comma. The Y value is
9.
right. Tell me the next point.
2 and 4.
Right? Sheena, what's the next point?
1, 1.
Right. All right. Who to call? Yvonne, what's the next point?
0, 0.
Right, 0, comma 0. What's the next point? Continue.
No, -1, 1.
Right. The next one will be -2, comma 4. And the
Yeah,
last one would be -3, comma.
9.
So tell me, Yvonne, you think we have enough points to plot that graph?
We know we're gonna have to draw big at
Yeah, so let me get this should be now we'd have to add in a 9 here. That's okay, we go use this for now. A temporary solution. All right. So let me start off with the first point, 3, comma 9. So I believe you all could annotate. Yvonne, start us off. Where would
Yeah.
3, comma 9 be?
3, 9 gonna be So you're gonna have to move vertically to
Like,
horizontally 3 to the right,
and then,
and then up 9.
right. So 3, 9 is gonna be over here. Yeah? So that's the first point. Nice. Now, typically, when we doing points in maths, you would draw the point like that. Or in physics, you draw the point like that. Technically, either one is correct, but we typically use this, right? We use that. So the first one is going to be 3, 9, and that's going to be over here. Right? Jada, help me with the second point. So I got tell me how to move. So I'm moving to the left, right, up, down, tell me. So we finished 3, 9. Cool. Next point is 2, 4. So tell me, Jada, how am I going to move? Okay, I'm hearing Jada. Shina, next point is 2, 4. Tell me how I'm going to move. Please, real quiet, boy. Vanessa, you hear me?
Yes, sir.
Okay. Thank you, Vanessa. The silence was
No, sorry, so right, button points.
yeah,
So moving to the right, to the 2, and then you're going up vertically to the 4.
right. Okay, what's next? Tell me, Vanessa. What's next?
You're gonna go 1 space to the right and then 1 space up.
Right? 1 space to the right and 1 space up right here.
Mm.
Joshua, tell me the next point.
Santa, that's Santa.
Yeah, 0, 0. Cool. Jira, you there?
Yes.
Right? So tell me the other point. So we're at -1, 1. So tell me how I would move to go to that point.
1 to the right and 1 up. Wait, no.
Take your time.
1 to the right and 1 down.
Nah. So remember, it's x first, then y. So x is -1 here. -1 would mean that you're going to the left. Right? Check it out.
Okay, I was reading it wrong side.
Yeah, so 1 to the
1
left,
to the left and 1 up.
right? Redeem yourself. What's the next point? Tell me how I would move.
2 to the left and 4 up.
Right. Next one.
3 to the left and 9 up.
So I trust that all your diagram would be better than mine. I trust I would actually use a piece of graph paper. Right? Because this is not it. Jira, notice that this graph looks exactly like this graph, and
Yes.
so Jira, you see when you change out the graph, you see why that was wrong? Because when you draw a graph, it actually corresponds to an equation. And the equation here was y is equal to x squared. That was the equation or the function. So by you drawing a different graph, you would have changed up that function. It would have no longer be y is equal to x squared. So you understand why that was wrong?
Yes.
Okay. So in maths, any function would generate a graph. And when you draw the graph, you can kind of see how the functions look like. Right? And this is an example of a quadratic curve. Right? Why? Because y is equal to x squared is a quadratic function. Right, so let's just connect the dots now. If I were to connect the dots, it would look a little something like this. Give me a second. Let me just draw this thing. So Yvonne, did I do anything so far that was confusing?
No, so we just do all of this in physics now, so not really confusing.
Okay, great. Right, so I trust that everybody understand what was done. Why this thing don't want to curve, boy? Okay. All right. And this graph will be the graph for y is equal to x squared. So all functions would look a certain way on a graph, piece of graph paper. Just remember that. And to plot a graph, you need points. To get points, what did we do? Well, we took our x values, we plugged it into the function, and that gave us y values. In doing that, we was able to generate coordinates, which is x comma y. Yeah. So Joshua, anything confusing here? Anything at all? Joshua? Can I hear Joshua? Who to ask? Sheena, are you confused by anything at all?
No, sir.
No? Okay. Right. So I'll let you do a sketch for now. And for homework, I'll let you draw the actual graph. So copy down what you have on the screen. So for the graph, what you had to do is you had to make sure that it goes from 0 to positive 9, and it goes from 0 to, well, it don't have to go to 9. It would just have to go, we could say it could go up to 5. So the graph you draw could be like this, and this could go up to 9. Yeah. So you could draw a graph like that. That would be fine. So Jada, did I do anything at all that make your head spin? You feel like,
No, not really.
nah, okay. And here, check this, right? You remember in a vertical line test, what we just do is we just draw a vertical line. Let me draw a vertical line over here. So if I draw a vertical line over here, Jada, tell me what's gonna happen. If I draw a vertical line over here, that passing through what value on the x-axis? Tell me, Jada, if I draw that vertical line there at that point, it passing through what value on the x-axis?
2.
And if I were to draw a horizontal line about that point, it would give my y value a what?
4.
So when x is equal to 2, what is y equal to?
4.
Does the points back that up?
Yes.
Yeah. So everything making perfect sense. Everything making sense. So I'm giving you all 3 minutes to copy whatever I have on the screen. Yeah, 3 minutes. And I go into, we have at 6:52. Yeah, we still have a little bit of time. I'll give all you to draw a really, really simple graph. A really, really simple graph. Nothing complicated at all. So you all could copy this down. So Vanessa, you never do functions in school as yet?
Well, in Form 2 we did.
Ah, okay. Did you all reach composite functions, inverse functions, something?
I cannot remember.
Oh,
Yeah. I think well, we on factorization right now and we almost finished, so
all right. Well, over the holidays we finished that, so you should be fine. You know, you
yeah.
should be matching that up.
Yeah.
But big up yourself. Right? Sheena, you never do this in school as yet?
What is it, sir?
You never do this in school as yet? Never?
No, we actually did like I'm always informed too.
Okay. Well, I'm glad to hear that you would I do this before.
But we did do it.
Right, so about 2 minutes remaining, a little less than 2 minutes. See how much you can copy down. Right after class, I'm gonna send these notes. So you're gonna have it. And I send my old Form 5 notes as well. So I'll have that there too. All right. Let's move on. Right? Again, I'm gonna give you a really, really simple function. Very, very simple. Right? So question. Given the function y is equal to 2x, plot the graph. So I'm going to give you all some x values to use. Now you're gonna notice that this graph is a line. So you don't need so much points. Jada, if you want to draw a line, how much points you need to draw a line? Tell me, Jada, if you want to draw a line, how much points you need? What do you think? Can I hear it, Jada? Yvonne, if you want to draw a line, how much points you think you would need?
You're gonna need around like the amount of the number, whatever. When the function, you're gonna need somewhere around that amount or higher.
Actually, you'd only need 2.
Oh,
Yeah, you only need 2. You didn't know that?
mm,
Check this out, right? If I have these 2 points, then I could just connect them.
yeah,
Would that make a line?
yeah.
Yeah, it would make a line. Vanessa, that confusing you?
No, not really.
Okay, cool. But I mean, just by looking at this, all you probably wouldn't know is a line. So let me just generate 3 points. So I'm gonna give Ollie some points to use, right? So Ollie could use x is equal to 0, x is equal to 1. Right. Let me give it to Ollie like this. So I give Ollie some points here, right? No points. I give Ollie some x values. Let's figure out the range for that. So Yvonne, if the function here is y is equal to 2x, if that is the function, if I put in x is 0, what am I gonna get?
If you put in what,
If I put in x is 0, what am I going to get?
you're gonna get 0.
If I put in x is 1,
You're gonna get 2.
x is 2,
We're gonna get 4
X is 3.
and then 9.
Nah.
Oh, 6. My bad.
So I want you to generate the points for me. So the first point is 0, 0. What's the other point?
1, 2,
The other point
2, 4,
and the last one.
3, 6.
Great. We're gonna plot this and finish this like very, very soon. Wouldn't take no time. All right, so the first point here is 0, 0. That's like right here. You know, this is 0, 0. The next point is 1, 2. 1, 2 will be over here. The next point will be 2, 4. 2, 4 will be over here. Yvonne, does it look like a line already?
Yeah.
Yeah, you can see it. Jada, does that look like it's gonna, if I connect those dots, would it be a line?
Yes, it would.
Yeah, it would. So let me just connect it real fast. I use red there. I'll just use red here. Right. Now again, I'm not drawing the most perfect graph. If you draw this on a graph paper, it will fall exactly on the line. If you notice here, it have a little distance, but that's fine. I think I'll get the gist of what I'm trying to say. Now, if you wanted, you could have extended this line. Yvonne, do you know how you would extend that line?
No.
Now watch. Let me show you how we would do this, right? So, and you would have to do this in physics too, right? You're going to take a ruler and you're going to line it up with these points here. I just showing you how you would extend the line, right, Yvonne? This is how you would extend the line. Did I confuse you, bad?
Nah.
No, okay, good. But in this question, didn't they give us a specific range of values, like 0 to 3?
Yeah. Yeah.
Yeah, so we will draw the line between 0 and 3. Yeah, cool.
Yeah.
And you would put the equation. So the equation for that line there is y is equal to 2x. Now, Jira, I want to show you something interesting. So if you do the vertical line test, right? At this point over here, x would be what? What would x be? Anybody can tell me. Not just Jada. Vanessa. If I do the vertical line test over here, right? X would be what?
2.
Nah, x would be what?
Oh, wait, x 1.
And y would be?
2.
Does that follow the equation of the graph?
Yeah.
Because it says y is equal to 2x. X would be 1 and y would be 2. So y would be equal to 2 by x, which is 1. Y is equal to 2. We see it now over here, right? What if we look at 2.5? If we do 2.5, we get in what, just from the graph. What do you think we get, Vanessa?
5.
Does that make sense? If the function is y is equal to 2x, does it make sense how we get in 5 for 2.5? Think about it. So if x is equal to 2.5, y is equal to 5. Does that make sense? Does that follow the equation?
Yeah.
Yeah. Yvonne, could you justify why 2.5, 5 is a point on the graph? If I were to ask you that, would you know how to justify it? Yeah or no?
We mean to like,
So if a point
yeah.
on the line, it should satisfy the equation of the line. So the equation here is y is equal to 2x. We got x to be 2.5 and we got y to be 5. Does that sound like it satisfies this relationship that says y would just be
Yeah.
2x?
Yeah.
Yeah, it does, because if you multiply 2.5 by 2, what you gonna get?
5.
Yep. And if you try 1.5, let me just say we do this. If you use the function, where's 1.5 by 2?
3.
If you read off the graph, where again?
We got 1.5, 3.
Exactly. So everything making sense, right?
Yeah.
So I show you the types of graphs. I mean the types of functions. I show you what is now a function. I show you how to test if it's a function or not, and I show you how to plot functions. Next class, we're going to look at inverse functions, composite functions, a lot more harder stuff. But before I go, any of you guys have questions? Anybody have questions?
No,
Sheena.
sir.
So I have only one question, right? But you never show it or anything. But I wanted to know how to find the gradient of a graph.
Okay, when we're doing coordinate geometry, I will show you. But
Uh,
if you have time right now, I can show you.
okay.
So to find the gradient, you just need 2 points. Any 2 points, but the 2 points have to be on the line, right? Have to be on the line. So could you
Yeah.
give me 2 points on this line here? 2 points on our line.
4 and 2.
Now, 2 points. A point has to be made up of an x and a y value. A point.
Oh,
So, for instance, this point over here. What's that point over there? What's this point over here?
that's 6.
No, a point is made up of an x value and a y value. That point would be 3,6.
Okay.
What would this point over here be?
That'll be 1, 2.
Great. So we could use these 2 points. So this point over here, don't want to leave it in the diagram, but we're using the points 3,6, and we're using 1, 2, yeah?
Yeah.
All right. So it doesn't matter which one you call x1, y1 and which one you call x2, y2. It literally doesn't matter. So Yvonne, which one you want to call x1, y1? 3,6 or 1, 2? Again, it don't matter.
3, 6.
Okay, we'll call her x1, y1, and we would call this x2, y2, right?
Okay.
Right? You lost or you're with me so far?
Nah, I'm with you.
We calling it x1, y1 because we calling that the first point, and we calling the other one x2, y2 because we calling the second point, right?
Okay.
Now the gradient is just simply the change in y over the change in x. So in other words, the difference of the y over the difference of x. So let me show you what I mean by that. So gradient will just be y2 minus y1 again, the difference of the y terms, or the change in y, over the change in x, which is x2 minus x1. So you understand now? Show you what
Yeah.
I did that formula before.
Yeah.
Okay. And so y2 here is 2 minus y1. y1 is 6. Okay. x2 is what?
X2 gonna be 1.
Right? What is x1?
Huh?
What is x1?
X1 is 3.
Right. What is 2 minus 6?
2 minus 6 will be -4.
Right. What is 1 minus 3?
-2.
A negative divided by a negative is a positive, and 2 into 4 is 2. You understand?
Yeah.
Let me show you something. What if you were to swap it? What if you call this x2, y2, and you call this x1, y1? Should anything change?
No.
No, let me see. So remember, gradient is y2 minus y1. If we're doing this, y2 would now become 6, right? 6 minus y1 in this case could be 2. x2 in this case is 3. x1 in this case is 1. 6 minus 2 is 4. 3 minus 1 is 2. 4 over 2 is
2.
same answer.
Okay.
And you could use, here what I was saying, right, Yvonne? You could use any 2 points on this line. You could use this point and this point. You could use this point and this point. You could even read off some points on your own. You could use that point and that point if you read it off correctly. You understand what I'm saying?
Yeah.
Once the point is on the line, you think you could use this point over here?
No.
Nah. right? So that's the basic concept of gradient. And you probably hear me saying change in y over change in x. That part confuse you? Change in y?
No.
Okay, good. Because watch this, right? If y2, if we say that y2 is, let me look at this example here, right? If we say in y2 is 2, so y2 is 2, right? And then we say in y1 is 6. See that?
Yeah.
So we have 2 and 6. Was it change from 2 to 6? Was it change?
4.
4, right? The x value here is 1, and the x value here is 3. Was it change between 1 and 3?
Yeah.
2. So the change in
2.
y is 4, and the change in x is 2. 2. Everything making sense. Yeah. You understand?
Yeah. Yeah.
Say no more. Right? So yeah, anybody have any questions? Anybody at all?
No, sir.
Okay, good. Right? Yvonne, this was your first session. How it was?
Good?
Was good? Nice.
Yeah.
Jada, this was your first session as well. How you find it was?
Very interactive.
You don't like that?
No, I like that. Learn.
Okay, good, good. So was the hype true?
Yeah, definitely was.
Say no more, say no more. By the way, any other coming from a TikTok page? Like, are they know my TikTok page? Yvonne, you know my TikTok page?
No.
Nah.
Yeah.
Shina and Vanessa, so you know my TikTok page?
Yes,
Yes.
sir. I would say.
Joshua, you follow any TikTok page?
Yes, sir.
Big up you. Yeah, Yvonne, I do video with Ravi B and thing, boy. You should really check my TikTok page.
Really?
Yeah, I was in Iran and thing, boy. I do a video where I was in Iran. You gotta watch it to experience it. Just look up Rajiv Dwarka on TikTok. Yeah. Yeah, well. See all you. See some all you just now at 7:30. So yeah, guys, it was nice meeting all you, the new people, and Vanessa and Sheena. Nice to see all you back. Right?
Yes, sir.
Later, everybody.
Bye. Thank you.
No problem. Bye,
Later,
guys.
sir.
Later.